Hi grade 11s, we're on to the fun part of grade 11 analytical geometry because this is pretty much the only new topic that we cover. So topic 4 is called the inclination of a line. So first of all, let's just discuss what this word inclination means. So in English we use the word inclination because it comes up quite a lot. The word inclination and the word incline come up quite a lot. So you would say, for example, gosh, the inclination of this hill is quite hectic, if you're running up a steep hill. Or in Cape Town, especially with quite steep hills, you would say like, I parked my car on such an incline, I was worried it was going to roll backwards. So inclination is about the slope of a line, really. And so our main question here is we need to understand the idea of an angle of inclination. So if you say that a line was at an incline, or a hill was at an incline, you mean it was at a slope. Now the angle of inclination, what I've done is I've drawn two Cartesian planes. The first Cartesian plane, I've drawn an upward sloping straight line, so that is a positive gradient. And the second picture, I've drawn a downward sloping straight line, which means it has a negative gradient. And I've drawn these two because these are pretty much the only two straight lines that you have. And so there's basically there's only one type of angle of inclination, but it can appear in two different ways. So the angle of inclination is the angle from the x-axis counterclockwise until you hit the straight line. That's technically the definition of an angle of inclination. So if I answer my question here, what is an angle of inclination? The kind of short answer is the angle a line forms with a straight line. The angle a line forms, I shouldn't say with a straight line, I should say the angle a line forms with the x-axis. So let me say that again because I was sounding confused. The angle of inclination is the angle that a line forms with the x-axis. Now, just to kind of flesh that out a bit, what I mean is if you moved counterclockwise from the x-axis till when you hit the straight line. So what we mean is the angle from the x-axis counterclockwise. So we all know that anti-clockwise would be another way to say that. Counterclockwise until you hit the line. So that's what it means, practically. So let me just say this again. The definition of an angle of inclination is the angle that a line forms with the x-axis. I think that can be ambiguous if I say just that, because then is it that angle there? If I put alpha there, is it that angle? Because that's an angle between the line and the x-axis. And so that's why I've written what I've written in green. It's the angle if you start at the x-axis and you go counterclockwise until you hit the line. That's called the angle of inclination. So in my negative gradient picture, if I start at the x-axis and I go counterclockwise until I hit the line, that will be the angle of inclination. That doesn't look like a very good theta. So let me draw it again. So that's the angle of inclination. Now notice that that's obtuse, which makes sense, whereas when the gradient was positive, this is an acute angle of inclination. So always start, when you're trying to draw in an angle of inclination, find your x-intercept, which is there, of your line, move a little bit towards the right, and draw from the x-axis to the line. And that's called your angle of inclination. Obviously, the bigger your angle of inclination, is an acute angle. So if I draw my acute picture, the bigger the angle of inclination, the more steep your graph is. And obviously, as soon as it goes to 90 degrees, then it kind of folds back, and then it's an obtuse angle. Right, so that's our definition of an angle of inclination. So let's look at example 1, which is going to explain to us what we're meant to know about this angle of inclination. Why is it important? How does it relate to analytical geometry? So let's consider the picture here. If I have a look at this graph, it's a positive shaped straight line. There is my x-intercept. If I just draw a dot there, if I go a little bit towards the right and I draw the angle counterclockwise until I hit the straight line, and I put a little theta there, that would be my angle of inclination. Now, if I just label this point A and pick a point there which is called B, now I'm going to call A x1, y1, because I don't really know those points. I mean, A could be anywhere. I just picked it there. It could be anywhere. I'm going to call B x2, y2. There's two things that I can figure out from here. So I'm going to go through this quite slowly because this is the whole point of angular inclination. If I dropped a perpendicular line down there, so it's perpendicular, notice I have formed a right angle triangle. And we should know from grade 10 that the important thing about right angle triangles is that we can use trig. So I have a right angled triangle. Now I'm not too sure how much trig you remember because we haven't done it in a while, but in a right angled triangle, this is the opposite and this is the adjacent. Okay, that's one of the ways we work in a right angled triangle. So let's have a look. Let me change color here. What would be the length of this opposite side? Well, I'm hoping that you would realize that I'm going up from y number 1 at A all the way up to y number 2 at B. So this here is my change in my y value. How far you've gone up is your change in your y value. Now, how far you've gone along is your change in your x value. So if I think of this as a little right angle triangle, my adjacent side, which is here, adjacent, is how far I've gone along the x-axis. So that's change in x. My orange side, which is actually my opposite side, if I think about in my triangle, is how far I've gone up, which is change in y. So if I have a look at this, if I said change in y divided by change in x, in this particular picture, that would be the side opposite theta divided by the adjacent side to theta. Now, again, I'm not too sure how much trig you remember, but opposite over adjacent is defined as tan of theta. So why this is important is we're now creating a mathematical relationship involving this theta. So tan of theta, I'm just going to erase everything from my picture for a second so that we can just reset. Here is B, here is A, here is theta. What I'm arguing is that if I drop down a perpendicular over there, I'm arguing that this is the opposite side and this is an adjacent side. And the opposite side is how far you have gone up, which is your change in y, and my adjacent side is how far I've gone across, which is change in x. So I just thought let me revise that by erasing everything, because that's quite a difficult concept. So I make a right angle triangle, I say what's the opposite side, which is how far I've gone up, which is change in y, what's the adjacent side, how far I've gone across, and so tan would be opposite over adjacent, which is change in y over change in x. Now, as I say change in y over change in x, you should be going, but hang on, I know something else about change in y over change in x. Change in y over change in x, that means y number 2 minus y number 1, how far I went up, divided by how far I went along. Now, hang on, wait one moment, that's gradient. So guess what? This is pretty cool. Change in y over change in x equals tan of theta. But change in y over change in x also equals gradient. So what's the important thing that we're meant to learn through this example? Tan of your angle of inclination equals your gradient. So you can say m equals tan theta or tan theta equals m. Now that's given to you on your formula sheet. It's a formula that that is widely known and accepted, and it's given to you. So it's not something you have to remember how we got to. It's not something you have to understand, really. I like it if you understand it, because it's actually really simple. But in reality, you just have to be able to use it. So let me just quickly recap here. I made a right angle triangle so that I could see what was the opposite side, what was the adjacent side, so I could use trig with theta. And I realized that opposite over adjacent was changing y over changing x, which means tan of theta is changing y over changing x. But hang on, changing y over changing x is gradient. So actually, your gradient is equal to tan theta. Now that kind of makes sense, that there's a relationship between the angle and the gradient, because the steeper the graph, the bigger the gradient, the bigger the angle. It makes sense that there's a relationship. And so this is the mathematical relationship between m and theta. So if you know the angle of inclination, you can work out the gradient. And if you know the gradient, you can work out the angle of inclination, which is pretty cool. So just one more note before we start looking at examples. Two important things to remember now. Let's look at parallel lines. Well, parallel lines will have the same gradient. So the gradient between C and D and the gradient between A and B are equal. And if your gradients are equal, and your gradients are equal to tan of your angle of inclination, it means your angle of inclination will be equal. So if you have parallel lines, you have equal angles of inclination. Now that makes sense on a whole nother level from grade 8 to 9, in that those are just corresponding angles on parallel lines. So if I look at F, like that, if I look at my F shape, those are just corresponding angles, so it makes complete sense that they have to be equal. And now it makes even more sense because the gradients are equal. Now that's actually the reason why corresponding angles on parallel lines are equal. In grade 8 and 9 we just teach you that as a fact, and finally in grade 11 this is the proof that corresponding angles on parallel lines are equal, and it comes from the fact that their gradients are equal, and so tan of theta has to equal the same thing here. Okay, the last thing I just want to note is that this theta, the angle of inclination there, is an obtuse angle. So because this is an obtuse angle, and you will note that the gradient is negative. So in this particular case, I'm going to say that tan of theta would be equal to the gradient of PQ. That's what we've discussed. Gradient is equal to tan of the angle of inclination, but theta is obtuse. Therefore, tan of theta will be negative because it's obtuse. So my gradient is negative and tan of theta is negative. So when tan of this angle is negative, you'll know that you have an obtuse angle because your gradient is negative. Okay, now that was a lot of talking and a lot of, okay, it looks easy-ish. So let's actually look at some examples because it really isn't too difficult. So example number 2. It says, consider the picture below. It's a straight line. I have labeled in theta. That's your angle of inclination there. I've given you 2 points. And question A says, can we work out the gradient of CD? Well, yes, I can. It's fairly easy. So my gradient of CD is change in y. So 6 take away 2 over 5 take away 1. Don't forget to don't have to show the formula, and you don't have to show any working. So it shows your substitution and your answer. So 6 minus 2 is 4. 4 divided by 4 is 1. Wonderful. Question B, can I work out theta? Absolutely. I know that the relationship is that tan of my angle of inclination equals my gradient. So therefore tan of theta equals 1. Now again, we haven't done trig in a while, so this is a little mini trig equation here. So how do I tell my calculator, here's the answer to tan, can you give me back the angle? Now, we can't do this. This is not tan of 1, because this is not theta. The angle's not 1, the answer's 1. So how do we do this? Well, I don't write this down in an exam, but you might remember that we do use shift tan. So we use shift and then tan on our calculator, and it says tan negative 1, which is basically how do I go back from the answer and give me theta. So then my calculator will say, great, theta equals 45 degrees. Now again, I don't show any working, but I'm going to, please make sure you write down those notes because we haven't done trig in a while. So don't forget, if you've got the answer, you go shift tan, and it'll say tan minus 1. So you're doing the inverse, you're doing the opposite. Then you put in 1, and you push equals, and you should get 45. Now in all of the examples we're going to do from here on out, make sure that you hit pause and try on your own calculator, because it's one thing to watch someone else do it, and then it's another thing to try and find those same buttons on your calculator. So try it for yourself. Okay, let's try example 3. Example 3 says determine the angle of inclination of, and there's a couple of lines we're going to work with. So what's the angle of inclination of y equals 2x minus 1? Well, first of all, what's the relationship between angle of inclination and gradient? It's tan of theta equals m. In this case, there's my m is 2, so tan of theta equals 2. And your next line should just be the answer. But how do I actually work this out on my calculator? I push the shift button, then I push the tan button, and it'll look like this on my calculator. It'll say tan minus 1. Then I put in the 2, and I push equals. Now that's because your calculator needs to know to take the answer back to the angle. So you should try it on your calculator, please, I beg of you. You should get 63,43 degrees. But we show no working. So shift tan of 2, and you push equals. Okay, on to the next one. Same question. Can I work out my angle of inclination? Well, I think I can, except this is not in standard form. So I cannot see the gradient until it is in standard form. We've spoken about this in previous videos. So first of all, I'm going to move the x over. Don't forget, standard form means y equals mx plus c. So I'm going to divide by 3. So this is actually negative 1 over 3 divided by 3, which is 2. So I could have written negative x over 3, but I like to be able to see my gradient. And so I've written negative 1 over 3. So that's my gradient. So now I know that tan of my angle of inclination will equal my gradient. So I say theta equals, and what I do in my calculator, I push shift, then I push tan, and what would it look like? It'll look like tan minus 1, and I put negative 1/3, and when I push equals, something happens. Now what happens? I get negative 18,43 degrees. Now what's happening there? I cannot possibly have a negative angle. I mean, my graph can't be, this just, how could I have a negative angle? This doesn't make sense. So please do include this drawing as an explanation to yourself. So what's happening is this gradient is negative, which means what am I expecting? Therefore, I'm expecting an obtuse angle, and I didn't get an obtuse angle. So I don't really know what this graph looks like, but I know it's a negative gradient. So I'm expecting an obtuse angle, and I haven't got it. I've got negative 18. Now this is just because of the way your calculator solves a tan equation. So what it's actually worked out is it's worked out that. Now it's minus because it's gone in the clockwise direction. Now when we actually do trig equations, we'll do this a lot and you'll feel more comfortable with it. But it's actually, remember, there's 2 solutions for a trig equation in the first 360 degrees. So what your calculator is doing is it's finding the other solution. Negative 18 is a solution to this equation. It's just not the one we want. So how do I go from this negative answer back to the answer I want? Well, I add 180 degrees. Because when I add 180 degrees, I'll get the obtuse angle that I want. So if I add 180, I get 161,565. So 161,57 degrees. So please put a very big asterisk next to this. This is really, really important. If you get a negative answer for the angle, you just have to remember, oh gosh, it's working out the wrong solution. How do I get the other solution? I add 180. So I'm just going to write myself a note because this is the only thing that's complicated about angles of inclination. So I'm going to say if you get a negative value for theta, you're not wrong. It just means you found the other solution. So you simply add 180 degrees, because that'll get you to the second solution of the equation, which is the one we want. Okay, definitely going to practice that one again. So let's have a look at the next one. Remember, the question was determine the angle of inclination of, and this question says the line parallel to y equals negative 2x plus 3. Now, parallel lines have the same gradient. You see, we try to push this point a lot. If lines have the same gradient, it means that if m here is negative 2, it means the gradient of the graph I'm thinking of is a gradient of negative 2. Now, the moment I say negative 2, that means my gradient's negative. I'm expecting an obtuse angle of inclination. Now, what's the connection? The connection is tan theta equals gradient. So in this case, tan theta equals negative 2. If I go to my calculator and I push shift tan, I will get that. I'll get tan to the minus 1 of negative 2. And when you do that, guess what? You get a negative angle. I get negative 63,43 degrees, which is not what I want. So this is exactly what we just discussed. How do I go to the right answer? I add 180 degrees, because it simply means it's found the other solution to the equation. So actually theta is 116,57, which makes sense because my angle of inclination had to be obtuse. So, good one to discuss there. Don't forget that if you get a negative angle, just add 180. Okay, next one says determine the angle of inclination of the line perpendicular to the line in question C. Now, the line in question C, let me just write it down. The line in question C was y equals negative 2x plus 3. Now, there's a couple of ways to do this question. I think maybe the easiest way to do it would be to say, right, perpendicular lines, this gradient is negative 2. So what's the other gradient? The other gradient is swap it round, so it's 1 over 2, and change the sign. So therefore, tan of theta equals, that doesn't look good, so tan of theta equals a half. And I should be able to go straight to theta. What am I doing on my calculator? On my calculator, I'm pushing shift tan, so it's tan to the minus 1 of a half. Now, the good news is that that's positive, and so I don't have to worry about the whole 180 thing. So I get, in this case, I get 26,57 degrees. Now, you might say, hang on, what's the second way? Well, interestingly, if I just get both of those answers, how do I go from there to there? Well, I'm minus 90 degrees. Why? Well, because these two graphs were perpendicular. So if I just draw in my little sketch an example of where this graph could be, the graph could be there. So if that's 90 degrees, and this is 116,57, I can just take away this 90, and I'll get that angle there. So I could have just minus 90. So two different ways to do that. Okay, last example of this intro to angles of inclination. Next question says determine the equation of the straight line with an angle of inclination of 135. Now, how does angle of inclination help me? The only thing I know about angle of inclination is that tan theta equals m, which means that tan of 135 will equal m. And if you push tan 135 on your calculator, now notice not shift tan, because this was just tan. So we weren't working backwards, so this is not tan to the minus 1, because you were working forwards. You were given the angle. So tan of 135 is negative 1. So now I know the equation is negative 1x plus c. And we've been practicing this concept. I have a point on the graph, so sub in my point, negative 1 times 2 plus c. So negative 4 equals negative 2 plus c, and c is negative 2. So don't forget to answer the question. The equation of the straight line is negative 1x or negative x minus 2. So I think the most important thing is the moment you see angular inclination anywhere, the only thing we know about angular inclination is that tan theta equals m. That's it. It's on our formula sheet, and that's pretty much all we have available to us. Great, so that's basically the introduction. We're going to, in our next video, we'll move on to more complex questions surrounding angles of inclination, but this is pretty much our only new concept. It is quite a different one. I mean, we're involving trig in analytical geometry, so it's quite fun. So definitely a good place to pause and practice this basic concept before we move on to using it in a more complex context. Okay, well done everyone. Keep going.